Hi, everybody. This is Matthew Poes of Poes Acoustics. And Nikolai Lorimer, you are on a roll. You gave me a donation of $9.99. I kept wondering why people were giving these very strange sized donations and then found out from my wife. Apparently, when you guys go to do it, it gives you recommended amounts for those. And they often are things like $9.99, which is so odd. Like, why don't they just pick a whole number? So thanks for the informative video. Looking forward to switching out my Class AB amps to Purify 9040s, which, for those who don't know, Purify has been releasing new versions of the amp. So they had one, I don't think it had an actual official name to it, but it was maybe like 7030 or 7020 or something like that. And then they came up with, I think it's the 7040 and now the 9040. So the first one, which I don't remember what the official model designation of that was, only has about, I said only, it's not bad, but it's only got about 20 amps of current, something like that. And the negative of having that amount of current is that when you go, so it doesn't really affect it at 8 ohms. And that's one of the issues with all amplifiers, is that current is not the main thing that tends to limit power at 8 ohms. It tends to be the rail voltage instead that the amp is operating at. And that would be even more true at 16 ohms, for instance. But in general, unless the current delivery capabilities of the amp are extremely low, usually the rail voltage is what limits things. When you go to 4 ohms, the main thing that allows the amplifier to double its power into that impedance would be the current delivery of the amplifier. And of course, the power supply needs to back that up too. But so then what happens in the case of that bottom of the line Purify amp, which is what I have in my system, is that instead of it going from, for instance, 200 watts to 400 watts, it goes to from 200 watts to like 325 watts or 350 watts, something like that. It doesn't really double. Does pretty good, but it comes a little short of that. And it's the current limiting that's the problem. So then when you go down to 2 ohms, what it means is that it really doesn't do much better than it did at 4 ohms, because at this point, it just doesn't have the current delivery to handle that. So they made the next module up from that, which I think was called the 7040. And that one up the current, it doubled it basically. And it made it so that it could actually go from, let's take an argument, 300 watts or 250 watts, something like that, to like 500 watts, 600 watts, something like that at 4 ohms. And then it actually had a good bit more power at 2 ohms. It also means that if you took 2 modules and bridged them together, which you can do with those, but there's a right way and a wrong way to do it. And I don't know if anyone's doing it the right way. But if you did bridge 2 together, you would get pretty much, I think you get like 600 watts into 8 ohms or something like that, because each one's actually seeing 4 ohms with an 8 ohm load. I don't remember the exact number. For those who are curious, and this is if you're going to buy one of these where they've bridged 2 modules together, talk to the company that's doing it and make sure they're doing it correctly. So there's a sense lead that goes on the output of the amplifier. When you bridge 2 amplifiers together, the sense leads need to move to the output of the 2 bridged amplifiers, so that it needs to be the point beyond that where they're connected together, and not the point at which it's mounted basically from the factory. The amp was designed for that lead to be able to be moved, basically extended and moved, but it doesn't come that way from the factory, and it's not simple. So because it's not super simple, like you just unplug it and move it, most of the companies that have done this didn't do that. And what that means is that if you were to look at the distortion and noise performance of the bridged module, it's substantially worse than a single module. But if you move the sense lead, it's about the same. And so you get really excellent performance. All right, so what are your thoughts on Class D amps that are offered with custom input buffer boards with discrete op amps? Is there an audible improvement to the sound, in your opinion? So I've actually heard the Purify and the Hypex modules with really expensive, fancy, discrete input buffers from a couple of different companies. And here's what I'll tell you. So Amir over at Audio Science Review measured a couple of these. I think they were the Hypex ones with those, and found that they were inferior to the factory buffer, which uses an extremely low noise discrete op amp. There can be advantages to upgraded buffers compared to the factory one, potentially, if it's doing something useful. Like it could be changing the input impedance in some way. It could have wider bandwidth. I don't know why you'd actually need that, but there's things you could do to make it better yet. But actually the one that Bruno designed on the kits and that was included in the Hypex mod were so good, they couldn't really be bettered all that much, if at all. There's a couple of designs I know floating out there. So March Audio their input buffer, which is uniquely theirs, it's not any worse than the factory one in terms of technical performance. And I know Bruno had said to me, it's arguably better than his own design. And he really liked what Alan had done with that one. So there are some designs out there that are better. Now, Alan's, by the way, is not a discrete buffer. So here's my issue with these discrete buffers. The argument is that because it's a discrete buffer, somehow it's going to sound better because it's got all these transistors that they've hand matched. Well, here's the thing. No amount of hand matching that these guys could actually afford to do, because you'd have to throw away 99% of the parts if you were, not literally, but you'd end up having to buy a ton of parts and then sort them. And you would throw away quite a few, or at least not use them on those discrete buffers to get the level of matching that these op amps have inside of them. Because that's what's inside those op amps, lots and lots of transistors. And so those are laser matched, laser trimmed on the boards when they're created, on the boards, but on the chip itself when they're created. The matching is so high, which is why the noise and distortion is so low, that it is not really possible to do these discrete buffers. Now you might say, well, yeah, but they're really small and they don't have a lot of current. You're right, they don't. But first off, you can use multiple op amps together to increase the current if you need to. And second, you don't need that. The buffer is just driving the next stage of the amplifier. So the input buffer is more than sufficient to do its job of impedance matching by basically providing an extremely high impedance at the input. I say that right? I think I said that right. I always get myself mixed up with that. And well, here, let's just look it up. I do this to you guys. Some of you hate this. You're like, can't you look it up ahead of time? Well, I don't plan what I'm going to say. So the Purify amplifier input impedance is 'cause you want a really, really low output impedance, but I believe you want a really high input impedance, right? Yeah. So the input impedance is extremely high, like 40 some odd thousand ohms or something like that. So you want a really high input impedance, you want a really low output impedance on the amplifier. So the amplifier has a very low output impedance. It's extremely low, which is what gives it its really good damping factor. And its input impedance is extremely high. So the buffer is what does that largely, and helps with that to ensure that you've got a good match there. It adds some gain. So you typically need a bit of gain. I think that I forget the exact number. It's like maybe 12.5 dB, something like that. Or maybe it's 12 even. But the gain of the Purify amplifier module itself, or those Hypex modules, is not that high, like 12 dB. And the vast majority of preamplifiers couldn't drive that thing to clipping. So you need to add something. Now, a lot of preamps just don't have a lot of voltage output to them. It's depending on whether it's balanced or single-ended, it's somewhere between 2 and 4 volts in many cases. And in those scenarios, you actually need to add a good amount. 15 to 20 dB of extra input gain ends up being needed to be able to ensure that the receiver or the preamp can drive that amplifier to clipping. It's not actually a good way to go. The better way to go is to have that gain stay really low. Keep it at like 15 or 16 dB total across the board. Make sure that the input buffer is the lowest noise and distortion possible so that it's not adding anything at the amplifier stage. But like, you could design something that effectively has no noise and distortion at all, in theory, as your input buffer. You could have an amplifier that has no noise and distortion, and you could still have audible noise and distortion at the output, because the input buffer is going to, obviously, it's going to reproduce string with gain, or wire with gain, right? Straight wire with gain. It's going to reproduce what's being brought into it, which has noise and distortion on it, but it's also going to amplify it. So if it's got 20 dB of gain, it's going to amplify the noise and distortion of the input by 20 dB. And that's pretty significant. So you also want to make sure that your preamplifier has significant voltage output and is operating in its most optimal range most of the time. And most devices have their lowest noise and distortion right next to where it clips. So if you look at a curve of noise and distortion based on voltage output, what you'll see is that the curve actually typically has a downward tilt to it. And what's happening is that the noise floor is pretty low. And if it's flat and then it goes up, so if it's like a completely flat line, then all of a sudden it shoots up, or it's actually like an angled upward line, that actually means the noise is very high on the device. And at no point until it starts clipping does the amplifier or receiver's distortion ever rise above the noise. And so that's not a good design. With any modern, well-designed product, what's going to happen is you'll see it actually look like a Nike swoop. It's going to go down and then it's going to come up. So what's happening is that the output of the device is swamped by noise at extremely low voltages. And then as the voltage gets higher, the signal level becomes high relative to the noise. And that's why the noise level, it looks like the noise and distortion drops. The distortion didn't drop. The distortion was constant at all those levels. It's the noise, and the noise didn't drop. It's just that the noise relative to the voltage became larger, the ratio. And so the noise and distortion as a percentage of that signal becomes very low. And then it's going to kind of level out. And then and that's your optimal range, that point where it starts to level out and that point where it starts to have like a inflection back up, a kick back up. Those 2 points are the key points where you want this preamplifier to operate all the time. It's also where you want your amplifier to operate all the time. And so the other advantages of these custom input stages would be that you could optimize gain for your preamplifier. But that's not really what Nikolai's asking. What Nikolai's asking is about specifically these companies that are selling discrete op amps because they're arguing they sound better. They operate in Class A and they don't have any switching distortion. And the problem is they actually have way worse noise and distortion than the part they're replacing. And the argument that they don't have switching distortion is kind of mooted by the point that the switching distortion levels of the part they replaced was already extremely low and arguably not audible. And they've actually added additional noise and distortion. So, does it improve the sound is a subjective question I cannot answer. Does it improve the performance is an objective question I can answer. And the answer is they do not improve the technical performance of the product, but they may improve the sound in that they may produce distortion that is more pleasant. And you may prefer the sound of the amplifier with some degree of intentional coloration. There's this argument that the amplifier's distortion hits a certain point where it's so low that it's not coloring anything, and anything you do to color the sound is actually a bad thing and not improving sound. I generally would agree with that. I'll give you a theoretical possibility that I don't think has been tested to such an extent that we can completely rule it out. One of the problems we have with figuring out the lower threshold of distortion detection for humans is that it's really hard to isolate those things to such an extent that you're 100% certain of what you're actually testing for the individual. And to make matters worse, many of the devices you would use would have distortion that starts to become high enough at certain points that it could be the device's distortion is swamping whatever you're manipulating for adding distortion. So we know, for instance, that masked distortion tends to be much less audible than unmasked distortion. We know that even order, especially second order, tends to have a more pleasant effect than odd order. So second order and fourth order is not nearly as bad as third order and fifth order. And then, again, we know that first, second, and third order are not as bad as seventh, eighth, and ninth order, something like that. So when they've done tests on all of this stuff, what they find is that second order distortion is actually not all that audible. It's easily masked. And the effect that it seems to have when the level gets audibly louder is actually pleasant. It's something that people like, within reason. You could call that a coloration. For third order, that's not as pleasant. It's not as well masked, but it's still better masked than others. And so the point at which people start to detect it is much higher than higher orders. Where I could see an argument is that these higher order distortion thresholds may be much lower than we realize. And it's possible that these Class D amplifiers with these op amps produce higher levels of higher order distortion than the audible limits, and that other devices which are coloring the sound ever so slightly, because these things are not horrific, they're just not as good as the factory parts, that those colorations would mask those higher order sounds in a positive way. That would be a good thing. Maybe this is true. I don't know. I'm kind of making this up as I go. The other possibility is that it's not harmonic distortion, but something like intermodulation distortion or some other form of distortion that, we're not really measuring with those metrics. So it's possible because THD actually correlates with hearing fairly poorly. So a ton of studies have been done to try to correlate THD and THD plus noise to, or SYNET for that matter, to human perception. And what they found is that the correlation is bad. It's not nothing, it's not zero, but it's bad. And there actually are much better metrics than THD. But all of the metrics that I am aware of in those studies, for the most part, were still focused on some sort of transfer function that relates to the harmonics. And it just was trying to do a better job of accounting for the fact that higher order harmonics are much worse than lower order, and odd order are much worse than even order. And so there are metrics that exist. Nobody uses them. Getty's actually developed probably one of the best. Nobody uses it. He was disappointed in that. But there's other types of distortion besides those, and we have a similar problem. The metrics we use may not actually reflect how we hear those distortions. And so our measurements, for instance, of intermodulation distortion may not be the best way of looking at that. So it's possible that these devices somehow have we'll call it better makeup of intermodulation distortion than the factory one, and that would make it sound better. The only way to really know that this is true would be to sit somebody down in a blind test and have them listen to both amplifiers under blind conditions and be able to tell you which one sounded better reliably. And nobody's ever done that. And quite frankly, I don't think anybody could. I don't think anybody would be able to hear the difference between the two. So what's my take? I would not bother to buy those. I don't think they're worth the money. They're very expensive. If anything, they seem to worsen performance. And I actually suspect that if anything, they're not audible. So even though they're making them technically worse, I think that they're still good enough that you probably couldn't hear the difference between that and the factory one. So stick to the factory one. The only reason I would change the factory one out is if the one that's being put in place is at least as good and has some other advantages like the ability to change the gain. So I hope that's helpful. Nikolai, thanks again for the donation and the wonderful question. Appreciate it. For the rest of you, subscribe to my channel. Keep on asking these great questions. The donations are always helpful and welcome. And keep on watching. I got more coming. Thank you.